What's up? Grab your pencils and let's get ready to grow those brains. Today we are tackling Unit 1. These are alternate instructions today. This is Lesson 18B, and I use it after Lesson 18 in the IM Geometry, but this is not actually from the IM Geometry. So if your teacher is not doing this and has just moved on to Lesson 119, Lesson 19, you may need to just move on to this. I do not do proofs by transformation, which is about what you're about to learn in the next several lessons. So I'll have slightly adjusted. You'll notice that I'll have this like gray background. I'm also, the PDF in the notes is always in the description, but these ones will have a practice worksheet in the description as well. All right, hopefully that is a good explanation of where we're going. So as always, though, we are going to start with a slight algebra review. So take this top row of questions, go ahead and solve for x. All right, we did some of these yesterday, so hopefully you should be feeling a little more comfortable with those. Remember, every time I am solving these, I'm always trying to get rid of my denominators. If I can get rid of my denominators, I can solve anything. Okay, we don't have to worry about those fractions. So I'm going to multiply both sides by x, and I'm going to multiply both sides by 20. Those x's and 20's cancel out. So then I am left with 20 times 4 equals 5x. I divide both sides by 5. You could reduce these. That 20 divided by 5 is 4, so 4 times 4 is 16. Or you could just multiply and then divide. Again, either way, 16 is equal to x. This next one, again, because the x isn't in the denominator, I don't have to work as hard. When the x is in the denominator, I've got to multiply by a lot of stuff. But this one, I don't need to worry about getting this 20 out of the denominator because he's already on the side that's not by x. So that's where I need him to be. I'm going to definitely cancel those 4's out. And I end up with x equals 5 times 4 over 20. Again, that turns into 20 divided by 20, which is 1. Again, this one, the x is in the denominator. When I see that x in the denominator, I know I need to multiply both sides by x because I've got to get it out. I have to move it. I cannot leave it in the denominator and still solve. I also need to get the 5 out of the denominator so that I can start to get my x by itself. So now I've got 5 times 4 equals 20x. I divide by 20 and I end up getting 1. Again, all of this is working because when we multiply both sides, usually, or we're going to get something to cancel out with that denominator. That's the whole point with that. And last one, again, the x is not in the denominator of either of these. He's up in the numerator. So all I need to do is multiply by 4. That allows those to cancel out. And I just get 1x is equal to 20 times 4 divided by 5, which is 16. All right. Now, today we are doing something a little different from the regular geometry lesson. This one is an introduction to proofs, and the IM Geometry does not have it, but I felt like it was missing. So I wanted to throw this in just to get us settled on what proof is. We're going to spend a lot of time in just this little bit of the end of this unit, but all of Unit 2 and a little bit of later units too, but especially Unit 2, we are going to be doing proof. And so you kind of need to know a little bit about what that's all about. Proof is based on conditional statements. You're always going to have a statement that has a hypothesis and a conclusion. All right. So what we call these is an if-then statement. If something happens, then something else will happen. So the if part is the hypothesis, and the then part is the conclusion. And math people, we are notoriously lazy. We want to write as little things as possible. So I'm going to represent my hypothesis with P and my conclusion with Q. So down here, it says underline the hypothesis and double underline the conclusion. I'm going to write P and Q. So if it is raining, the condition is that it has to be raining, then we know that there must be clouds in the sky. So one line for here and 2 lines for here. My P and Q, and that is a Q, not a 9. He kind of lost his tail there. All right, so we use these kind of statements all the time, but we don't always say the if and the then. So again, this is a conditional statement. If the first thing happens, then the second thing will happen. So I want you to try and pause. Again, we're just trying. I know this is new, so make an effort, write something down, and if it's wrong, that's okay. But this is where your brain grows when you try and do this on your own. Try and rewrite this conditional statement as an if-then statement. So you're going to write if blank, then blank for both of these. All right, now you may have something a little bit different. And again, you're just learning, so don't be surprised if you're a little off. This started out by giving us a 90-degree angle. Sorry about that star, that should be a degree. I'll have to work on that. So if an angle is 90 degrees, that's the thing I have to start with, then it is a right angle. That's the conclusion. So if and then, again, this is my P, this is my Q, one underline here, two for that. Over here, notice that it's not always just the first thing and then the last thing. This one said because x equals -3, because means that had to happen first. So that's why this, if x equals -3, again, that's my P, then 2x plus 7 equals 1. And if you plugged that in, again, you would have 2 times -3 plus 7 is -1, and that does check out. That's totally true. So again, this is new. It's not necessarily about the order, it's about the condition. What condition has to be met for the other thing to be true? All right. So deductive reasoning, it is the way we are going to use our proof. It is a logical argument that is formed by facts, definitions, and laws of logic. Did you know that there were laws of logic? So what we're going to take is just kind of a conclusion process through if we have a conditional statement, that's the if-then statements. If it is true, then both the hypothesis and its conclusion will be true. So when given a different form of the hypothesis, we can make a conclusion from the conditional statement. Now, quite honestly, this direct argument can often be called just plain old common sense. Okay, you're going through, you're saying one thing. If the hypothesis is true, then the conclusion is true. So some form of that hypothesis being true also leads to the conclusion still being true. You guys use this kind of logic in your writing and just making common sense observations all the time. We just don't talk about it as logic. So let's look at a couple of examples. So first off, we have in this one, we're using the law of detachment to, or direct argument to make a valid conclusion. So it says that every weekday, that's my P part, John goes to the gym. That's my Q part. All right. So what they're telling us is, well, today is Wednesday. So then what do we know is going to happen to John? Well, it's a weekday, right? Wednesday is a weekday. So my conclusion is that John will go to the gym. All right. So not too complex. Again, it wasn't a weekday specifically, like that's not what it said, but Wednesday is a weekday and that's why it fit. It was some form of the hypothesis. So this next one says if two angles have the same measure, then they are congruent. And then it gives you this example of the measure of angle A is equal to the measure of angle B. So again, this is my P and this is my Q. So this is a version of my P. It's not just any two angles, it's specifically angle A and angle B. They have the same measures. So my conclusion can be that angle A is congruent to angle B. All right, next piece. We're jumping on the next page. The law of syllogism is the chain rule. And I'm going to tell you right now, I'm going to learn how to figure this out. I'm going to put a link somewhere on this page because I want you to watch a commercial. It was a commercial for DirecTV, I think. Um, and it was all about the if um, if you pay too much for cable, that was the if statement. And then in this advertisement, the conclusion is that you'll get attacked by a lowland gorilla. Actually, I think the word is body slammed by a lowland gorilla. Again, I'll put a link to this because it's pretty great to kind of think about the chain rule. And what the chain rule says is that if you have a hypothesis P and then a conclusion Q, and then another statement has the hypothesis of Q, and the conclusion for that is some other thing R, you can keep building like that. So again, if P, then Q, and if Q, then R. Therefore, if P, oh, wrong color, if P, then R. You can kind of skip this middle part where you overlap those Q's. This is also called the transitive property. That's what he's closely related to. So if the hypothesis P is true, then eventually the conclusion R is true. So it's the hypothesis of the first statement and the conclusion of the last. Kind of just gets rid of the middle. All right. So if you haven't yet, go ahead and watch that lowland gorilla commercial. It's pretty great. And see how they eliminate the middle to finally get with this. If you pay too much for cable, you'll get body slammed by a lowland gorilla. All right, so let's go ahead and look at these. If possible, use the law of syllogism to write a new conditional statement so that follows from the pair of true statements. So with this, we have to be really careful about making sure we're eliminating the middle. So for this first one, I'm going to definitely color code here. If Rick takes chemistry this year, then Jesse will be, oops, different color. Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A. So you can kind of see how I'm eliminating that middle part that's repeated. Jesse will be Rick's lab partner. So my conclusion is that if Rick takes chemistry, then Rick will get an A. All right, kind of ran out of room there, sorry. So on this one, you can see for sure if Rick takes chemistry this year, then Rick will get an A. So we left that middle Jesse Rick part lab partner bit. So go ahead and look at this one. And the weird thing about this one is it's kind of a little weird, right? What it's got an if and a then that is repeated, but let's see if it makes sense. So if x greater than 5, then x squared is greater than 25. And if x squared is greater than 25, then x squared is greater than 20. All right, so this guy, he's kind of going backwards. You have to watch out for him. So unlike before, where they were already kind of naturally in the correct order, this one's a little messed up. What you have to do is read this guy first. If x is greater than 5, then x squared is greater than 25. And then you're going to come read this guy. And if x squared is greater than 25, then x squared is greater than 20. So the thing that's crossing out that I'm skipping is that middle piece, but it doesn't necessarily mean it was written in the exact same order that we had before. So watch out for that one. So I'm going to look at this one, C, and where do you see that repeating piece? If a polygon is regular, then all angles in the interior of the polygon are congruent. If a polygon is regular, then all of its sides are congruent. Notice that both of these guys are my if part, right? both of these are if. So this is not transitive. He does not work. Okay. This is all one big if statement. And then these two things, these then statements can come from it, but I'm not going to be able to skip anything. There's no, it's not transitive. There's nothing I'm pulling out of the middle. So again, he has a problem. It's not going to work. Again, proof is a logical argument that shows a statement is true. There are several formats for proofs, and a two-column proof is the one I'm going to focus on the most. Your textbook likes to do paragraph proofs, which can be excellent ways to do it, but they can be difficult for people who just don't like to read. Honestly, sometimes you guys love math because you don't have to read in here, at least as much. So I'm going to use a two-column proof. It is not the only way, but it does have numbered statements and corresponding reasons to show an argument in a logical order. Again, the reasons in a proof can be usually one of four things. One could be definitions. One could be properties. One could be theorems. And also you can use postulates. Those are the most common things that we are going to use in our proof. And again, this is just like writing. When you are writing some sort of argument in a class for an essay, you come up with some sort of this is what I think, and then you make sure that you can show me why you think that way. As for properties, I need to give you guys a couple of properties. You use mathematical properties all the time. We don't just always talk about what those properties are. So we're going to talk for a minute about the reflexive property of equality, the symmetric property of equality, and the transitive property of equality. You've already got a little bit of idea of what that might be. So this can work for, I've got three different examples here for each of them: real numbers, segment length, angle measure. So those are my three options here. So anytime I have a real number, it doesn't matter what it is, 7, 12, 5, I'm just going to call it A, it equals itself. Notice that this guy, the reflexive, he's like reflecting in a mirror. He reflects back itself. So for any segment AB, I know that AB equals AB. And finally, for any angle A, I know that angle A is equal to angle A. And I hope right now you're having like a well duh moment, because yes, this is a well duh thing, but we will use this one. You'll be surprised how many times we need to identify that something is the same as itself. And sometimes we've just got to make sure we lay out the obvious. So we will do that as often as we need to. Next one, symmetric. We talked about symmetry a little bit already this unit. So symmetry is something you're a little familiar with. Think about a line of symmetry and how you were like reflecting things over a line of symmetry. That's what this is going to be like. So this one kind of just changes our order. For any real numbers A and B, if A equals B, then B equals A. Being able to switch the order is important. Same thing for segments. If AB is equal to CD, then what is it? Absolutely, CD is equal to AB. And for angles, angle A, if it's angle A is equal to angle B, then angle B is equal to angle A. And I should have a little M for the measures. Usually we talk congruent when we're just talking about the angles. Talk equal when we're talking about the measure of the angles. All right, last one, again, that transitive property, it's the one that kind of drops out the middle piece. So for this one, if A equals B and B equals C, notice that that A and B happening in there, I can drop those. Then A equals C. Same things for segments. If AB is equal to CD and CD is equal to EF, I can drop the middle and say then AB is equal to EF. They're both equal to the same thing. They must be equal to each other. And then finally, again, if measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, then I should be able to say that the measure of angle A is equal to the measure of angle C. All right. Now, as I stated before, there is no practice for this kind of stuff in your textbook, in your workbook. So in the description on the YouTube page, there is this practice here that you can work on. This is great opportunity to practice those ideas and get familiar with the properties that we are going to use, and just kind of the chain rule and the idea of proof. One thing leading to another, leading to another, leading to another. Boom, we are done. Make sure your notes are complete. Write down any questions you still have and keep growing those brains. See you in class.